All right, today we're going to start 3.2. It's all about adding and subtracting linear expressions. So if you would pull out your red pen, and I want you to fill in these couple things for me, please. Okay, so the first thing that we wrote down was a linear expression. This is an algebraic expression where the exponent of each variable is no higher than a 1. Let's look at this example right here. X to the third power. What is that exponent, Luke? What number?
It would be 3.
It's a 3. Very good. Okay, Abby, x squared. What is that exponent? Jonathan, what's the exponent? It's a 2. Okay, let's look at this next one. X to the fourth power. Class, what's the exponent? 4. Okay, so with a linear expression, it's an algebraic expression where the exponent is not higher than a 1. So these right here could not be linear expressions if we were graphing them because their exponent is bigger than a 1. Okay, so for example, these are some examples right here. 4x, it basically has an understood 1 right there. 3x plus y, these have understood exponents of 1. 5 minus 1/6x has an exponent of 1. Let's look at these down here. 1/6 x squared. Class, what is that exponent? What is it? 2. More than just Jonathan. Guys, what is it? 2. Very good. Let's look at this next one. X to the fifth plus 2. Jacoby, what's the exponent? 5. Very good. And the final one, Jace, 4x cubed. What is the exponent? 3. Very good. Okay, so we're looking at the linear expressions will have a variable that's not higher than a 1. Let's do some work kind of like what we did last week. X minus 2. There is no need for us to keep these parentheses here. Now, in order for us to underline and circle, we cannot have parentheses there because there's nothing that's here on the outside that's telling me I have to distribute it to everything on the inside. I am allowed to drop this down without having the parentheses. So everybody drop down x minus 2. Anytime we have a plus sign on the outside, we are very happy because when we are adding things, I'm allowed to drop down the plus sign and I can bring everything else down that's inside of the parentheses without having to do any extra work. Now this is exactly like what we did on Thursday and Friday of last week. So now we're going to underline those that are in the same family. Jocelyn, who's in the X family here? 3x, who else? And just plain old x. Now there's an understood what number in front of that x, class? A 1. Let's go ahead and put a 1 there. Jocelyn, what are the constants? Remember guys, a constant is a number that stands alone. 8 and not 2, -2. Good job. Remember that saying, guys? Every number has a sign, and that sign is directly in front of that number. All right, Regan, what is 1x plus 3x? 1 plus 3x. What's 1 plus 3?
4.
4x. Very good. Okay, so we are always going to do our variable term before we add our constants together. Regan, what is -2 plus 8? +6. Very good. Okay, and I like that you said +6. We need to make sure that we always have a plus or a minus in between each term. Now, on your homework that you guys did on 3.1, I saw a lot of people that told me their final answer was 10x. This is not correct. Why is the answer not 10x? Good job. They are not like terms, so you cannot add those together. This is as simplified as it can possibly be. So 4x plus 6 is my final answer. All right, let's look at problem B. Abigail, do you see any need for me to keep the parentheses right there? No, there's nothing on the outside that I have to distribute, so I'm allowed to drop it down and get rid of the parentheses. Remember, you are never allowed to underline and circle if there are still parentheses in the original problem. So that's what right now we're trying to get rid of those parentheses. Jonathan, I have a plus sign right here. Because that's a plus sign, do I need to do anything to the things inside of the parentheses? No, I do not. Okay, so I'm allowed to, once again, it makes us very happy when we see a plus sign in front of parentheses. I'm allowed to drop down the plus sign and bring down everything in the parentheses afterward, but I can leave the parentheses behind. Now, once again, this is a problem that we did just like in 3.1. We're allowed to underline and circle the like terms. Maddie, what is in the Y family? Okay, negative 4y and positive 11y. Now I'm wondering, what are my constants, Maddie? Very good. Thank you once again for saying negative 5. Now let's combine these things. The first thing I want to combine right now is the Y family. Jace, what is negative 4y plus 11y? Same sign, add and keep, different sign, subtract and take. Very good, 7y, and that's going to be a positive because the 11 was bigger. Jacoby, what is positive 3 minus 5? Negative 2 is correct. Once again, this is what I saw on the homework. Is this correct for my final answer? No, they are not like terms, which means you cannot combine 7y and negative 2. No matter how much Abigail and Reagan like each other, they're not in the same family, okay? These guys, no matter how much they want to be, they're not in the same family, so you cannot combine them and try to make them in the same family. Next up, find the difference. Anytime you see this word difference, that means we are subtracting, okay? So this is where things get a little bit trickier. Let's look at the first things, though, right here. MJ, do I need the parentheses around 5x plus 6? No, I do not. There's nothing on the outside that needs to be distributed, so I'm allowed to drop that down and get rid of the parentheses. Here is where it gets tricky. When you have a negative in front of parentheses, it's not so easy. You cannot just drop things down. Technically, I want you to take your red pen and I want you to put a minus 1. In this case, I am subtracting one of these right here. I'm subtracting negative 2x plus 6 one time. Because of that, I have to distribute that negative 1 to everything on the inside. So take your red pen and I want you to draw an arrow to the first term and then draw an arrow to the second term. As we do this now, let's focus on this first part right here. Negative 1 multiplied by negative 2x. Help me out with these. Just if I'm multiplying by 1. Guys, what's 1 times 5? 5. What's 1 times 10?
10.
What's 1 times 3?
3.
What is 1 times negative 2x? Okay, anything multiplied by 1 is going to equal itself. Now here's where it gets tricky. I am multiplying a negative times a negative, so my answer has to be a positive. When I am multiplying two negatives together, that's an even number, so they have to become positive. Now, class, what is 1 times 2x? 2x, very good. So now there's still one more thing. I have to multiply the negative 1, and this arrow says to multiply it times positive 6. What is a negative times a positive? We are multiplying. There's only one negative there, so is my answer going to be positive or negative?
Negative.
It has to be a negative, okay? So negative, and then what's 1 times 6? 6. So at this point, you are having to think. Remember, whenever there's a number outside of parentheses, that means to multiply. So there we were using our multiplication rules. Now we're going to come back and find some like terms. Jace, who is in the x family? 5x and the 2x. Everybody underline that with your pencil. Jace, do you see any constants, any numbers that stand alone? Very good. Now we're going to combine our like terms. Jocelyn, what is 5x plus 2x? 7x is correct. Maddie, what happens here to positive 6 and negative 6? Are those the same sign? No. That's a number and its opposite. Class, what happens to a number and its opposite? It equals 0. So you could just take your pencil and get rid of those. Okay, so the correct answer would be 7x. All right, moving on to the next one. Once again, we're still finding the difference. First things first. Abby, do I need to keep the parentheses around the first terms? No, I do not. So because there's nothing in front of it for me to have to distribute, I can just drop down 7y plus 5. Unfortunately, we do not like it when there's a negative in front because I need to distribute that negative. Remember, that is like having a negative 1. Everyone take your red pens and put a little 1 in there. Remember, we have to distribute the negative 1 to the first term and draw an arrow to the second term. We have to be fair and distribute it to both terms. All right, go ahead and put those red pens up at the top. Now let's focus on this first term. Negative 1 times positive 8y. What would that be? Negative 8y. Now we're going to focus on multiplying negative 1 times negative 6. When I have two negative numbers multiplied together, that's an even number of negative signs, so my answer has to be positive. Plus, what's 1 times 6? 6. Very good. Okay, so remember, it just gets a little bit tricky whenever we have this negative on the outside of our parentheses. But now my problem looks normal again. Jacoby, what should I underline for like terms?
7y and 8y.
Not 8y, but negative 8y. Okay, just remember, every number has a sign, and that sign is directly in front of that number. All right, Jacoby, what should I circle?
The positive 5 and the positive 6.
Very good. Class, what are those numbers that stand alone called? Constants. Very good. Let's focus now on my 2y family. Luke, what is 7y minus 8y?
Negative 1y.
Negative 1y. Very good. Now, you could just say negative y, or you could slip in that 1 there if you wanted to, but you don't have to have it there. Okay? And Luke, what is plus 5 plus 6?
Positive 11.
Positive 11 is correct. Those are different families, so there is nothing else that I can do to simplify that anymore. Now listen, I would say the way that we just did this problem is slightly difficult. There is a way that I would like to teach you that, in my opinion, is a little bit easier. So I want you guys to write the original problem. There's a little bit of room that you've got there to the right of the problem we just did. I want you guys to rewrite the original problem, and I'm going to teach you an alternate or a different way that you could do this problem that, in my opinion, is a little bit easier. So if you have not yet, please rewrite the original problem. You're just rewriting this problem right here to the right. Once again, you've got a little bit of space there to the right of that problem, so go ahead and write the original problem one more time. All right, let's start off like we normally do. Is there any need for us to have those parentheses on the first one, class? No, there is not. So you can drop it down without having the parentheses. Do we like it when there is a minus or a plus sign in front of the parentheses?
No.
Which one would we rather have, a minus or a plus? A plus. So here's what I'm going to do. I'm going to give you permission to get rid of that minus sign there and turn it into a plus because we like plus signs better. Now here's the deal. You can't just go changing positives and negatives opposite to whatever you want just to make it correct. So there's a rule that happens anytime that I give you permission to do that. Do you see this first one right here, 8y? Is that a positive or a negative? Positive. It's a positive. If I give you permission to change these signs out here to the opposite, you will then have to change everything on the inside over here to the opposite of what it is already. So we have a positive 8y. We need to change that now to a negative 8y. Let's look at this one. I have a negative 6. I have to change it to the opposite. What's the opposite of negative 6? A positive 6. Once again, this is me giving you permission to change the signs, but only if you change the signs on everything that comes in those parentheses. All right, make sure you're really following along because this is a tricky concept. Now, we don't like double signs. Do you see this plus minus side by side? Who always wins? The negative always wins. Okay, so if you're adding a negative, it just means you're subtracting. Now my problem looks normal again. Let's go ahead and underline and circle the like terms. Jacoby, what's in this y family?
7y and negative 8y.
Good job. MJ, what's in the constant family? Positive 5 and positive 6. Very good. Everybody, let's focus on the y, because remember you have to do the variable term before you do the constant term. What is 7y minus 8y? Negative 1y. Okay, now do I need to put the negative 1 there, or can I just put negative y? Okay, I do not care which way you did it. I'm just going to put a negative y. Now let's focus on our constants. Reagan, what is 5 plus 6? 11. Positive or negative 11? Very good. Remember, in between each term, you will always have to put either a plus or a minus. In this case, it's a positive, so that means we are adding them together. Now, I want you to focus on this. Was that the same answer we got the other way?
Yes.
Yes, I just taught you a new way or a different way to do it. Okay, I want you guys to go to problem 2A. If you would, please, we're going to do this the same way we just did that other problem. I want you to rewrite to the side the original problem. Okay, I know there's not a ton of space, but make sure you're putting it in there. You're rewriting that original problem, and we're going to do it our new way to see which way you guys prefer to do these problems. Remember, once again, you're just writing this to the right of that original problem where we did all that work. Okay, first things first, Jonathan, do I need these parentheses right here? No, I do not. There's nothing in front that tells me I have to distribute a negative sign or any other number. So I can get rid of those parentheses and drop everything down on the inside. Jocelyn, do we like it when there are negatives on the outside? No, it's a lot more work. So I give you permission to do the opposite. Instead of subtracting, what am I giving you permission to do? Add it. Everyone drop down the plus. Because I changed the sign on the outside, what do I have to do to every sign on the inside, class? Change it to the opposite. Instead of negative 2x, what will it become?
2x.
Positive 2x. Do you think it is necessary for me to put plus 2x? No, I don't think so either. So we can just get rid of one of those plus signs. Now, instead of plus 6, I will put what, class? Negative 6 or minus 6. Now we have a problem that looks much easier to be able to do. MJ, tell me what to underline and circle.
5x and 2x underline.
Very good.
And then positive 6 and negative 6.
Excellent. MJ, what is 5x plus 2x? 7x. And MJ, what happens to plus 6 minus 6? It becomes a 0. Those cancel out, and our final answer is 7x. Is that the same thing we got the first time?
Yes.
How many of you would say you like this way that I taught you where you distribute the negative 1? Okay. How many of you would say you like this other way a little bit better where you can change the negative to a positive? For me, this is the one that makes me happier. So from now on, I am going to do it this way, the second way. However, on a quiz or a test, when you have that, I do not care which way you do it because as you can see, you're going to get the same answer no matter which way you do it. All right, the next section is a think, pair, share section. So what I want you to do is try to do problem A on your own. If you get stuck, look at your notes on some of the examples we just did. Okay, let's see how you guys did. As you can see, we do not need the parentheses on either of them because there's positives in front of both of them. Let's underline the like terms. That's the x family, and this is the constant family. Negative 8x and positive 8x. What can happen to those, class? They can cancel out. Remember, a number and its opposite always equals 0. So what is my final answer? Negative 3 is correct. 2 thumbs up if you got that answer. All right, if you did not, that's okay. Erase it and fix it so that it looks like mine. All right, let's go to the next one. Luke, do I need the parentheses around the first one?
No, ma'am.
No, I do not. So we're going to get rid of them. half w minus 3. Abby, do I need the parentheses around this one? No, because there's a plus in front, I'm allowed to drop down the plus, and everything else behind it can get dropped down without the parentheses. To Kobe, what should I underline and circle for like terms?
1/2 variable w and the 1/4 variable.
Very good. And what should I circle?
The -3 and the +3.
Excellent. The first thing we want to always do is our variable terms. So I'm going to add my variable terms together. I am adding together the W family, but what do I need to do with these fractions in order to add them? Reagan?
Make them a common denominator.
Correct. I need a common denominator, 1/2 plus 1/4. Reagan, what should my common denominator be?
4.
A 4. So what do I have to multiply this by to get it to become a 4?
A 2.
A 2. Very good. What does this fraction then become?
2/4.
2/4. Now I am adding 2/4 plus the 1/4 we had before. Reagan, what's 2/4 plus 1/4?
3/4.
3/4 is correct. And what family was that in? This has a variable with it. What variable is that?
Oh, the W.
The W family. Okay, so we've got to keep the W there. Now, Reagan, what happens to -3 and +3?
You subtract them.
Okay, you subtract them.
Be 0.
And it would be 0. A number and its opposite always equals 0, so the final answer is 3/4 W. So today we have one last and final problem, problem C. I want you to try it on your own, but notice the trickiness we have here. It is a subtraction sign in front. So remember, you can look at your examples up above where we find the difference to see what it is that you need to do. All right, let's look at this right here. I don't need the parentheses on the first one because there's nothing on the outside I need to distribute. Now, the next one, remember, we don't like it when there's negative signs in front of the parentheses because that means I have to distribute that negative sign to everything on the inside. So I'm going to change my negative to a positive because we like dealing with positives instead. But that means everything on the inside has to change to the opposite. Instead of positive 6.3c, what will I have? Negative. So I'm adding this in as a negative 6.3c. Instead of a positive 20, what am I going to have? A negative 20. How many of you would say you remembered this much at least and you got this far? Okay, if you did not, if yours is messed up, erase it and fix it. Was there anyone who said that you put the -1 here and you distributed like this? Okay, we did have one person who did it that way, which is fine. I'm going to show you the other way and then we could check that way also. Let's focus on this. Positive, negative. Who always wins? The negative. So I'm going to get rid of that extra plus sign, which means I am subtracting it. Let's underline and circle the like terms. This is the C family and this is the constant family. I want us to focus on the C family right here. This is where a lot of people made their mistake. The -2, okay? I have the same sign, so I have to add the numbers and keep the sign. 2 is the same thing as 2.0, isn't it, guys?
Yes.
Okay, then I'm adding the 6.3. When I add those together, I would get 8.3. Now, that was in the C family, and those were negative, so I have to keep the sign. So that would equal negative 8.3c. How many of you would say that was where you made your mistake? That's okay. If you forgot the negative, slip that negative in there. Some people instead added like this, 6.3 plus 2, and they got 6.5. Be careful, you have to line up your decimal points, okay? So you don't want to do that. Now let's focus on the constants. Positive 5, negative 20. Same sign or different sign? Different sign. Subtract and take the sign of the larger number. What's that part? Negative 15. All right, please make sure that your answer looks like my answer, even if it looked differently to start with. So, tonight's homework is over the lesson that I just taught you. There are only 9 problems, and I'm going to give you some time right now to go ahead and work on that.